Preparation methods of alkynes. 4 preparation methods I will be talking about: from calcium carbide, from vicinal dihalide, from tetrahalides, and preparation of higher alkynes from lower ones. Lower ones will give you higher alkynes. We will use alkyne to produce higher alkynes. Out of these, 2 are given in NCERT. First 2 are given in NCERT, but the third and fourth are also important. Questions appear from there very regularly. So you can't skip third and fourth as well. So the first one, from calcium carbide, the actual reaction is this one. Calcium carbide reacts with water and gives us slaked lime. Calcium hydroxide is slaked lime, and acetylene. Okay, acetylene means we have ethyne. Now the point here is that we have 2 extra reactions here, and those reactions are just to produce calcium carbide. We don't actually store calcium carbide. So first we get calcium carbonate heated, we get quicklime and carbon dioxide. This quicklime is treated with carbon to get calcium carbide. So these first 2 reactions are actually just the supporting reactions. Main reaction is this one. Main reaction is this one only. So from calcium carbide, it is CaCO2 plus water. You get slaked lime, calcium hydroxide, and ethyne, C2H2. Just memorize this reaction. This is the main reaction. And then you can recall that, yes, calcium carbide is produced from calcium oxide. And calcium oxide is produced from calcium carbonate. So calcium carbonate gives us calcium oxide, that is quicklime. This is, come back, where are you running? This is quicklime. Quicklime reacted with carbon gives us calcium carbide. Calcium carbide on treating with water gives us slaked lime and ethyne. Next one, from vicinal dihalide. Vicinal, I have talked about in previous class as well. Vicinal means in the vicinity. Adjacent carbons have halogens. 2 halogens. Dihalide means 2 halogens are on adjacent carbons. Those compounds are known as vicinal dihalide. So you have vicinal dihalide here. It is CH2Br, CH2Br. Okay. It is CH2Br, CH2Br. When we get it reacted with alcoholic KOH, remember alcoholic KOH. Alcoholic KOH, we get alkene with 1 bromine less here. Now in few books, this as a conversion, it is written that this can replace both the bromine and hydrogen. Means it can do dehydrohalogenation. This is something we have already talked about. If you remember, in preparation of alkenes, I talked about dehydrohalogenation is done by alcoholic KOH. Dehydrohalogenation. So you should remember, dehydrohalogenation means hydrogen and halogen removed. D means removed. These are removed by alcoholic KOH. So we are doing the same thing here. Okay. We are removing the bromine from 1 carbon and hydrogen from another carbon. So it is actually minus. Here it is written KBr. Actually, it is combined. When you write, it is minus HBr. Hydrogen and bromine removed by KOH. And you will get alkene. After that, it is not vicinal dihalide. Okay. It is not vicinal dihalide. It is single halide. And here you have double bond. Okay. Here you have double bond. Because here you have double bond, you cannot use direct KOH, alcoholic KOH, to do further dehydrohalogenation. Remember, to get from here to here, it is again dehydrohalogenation. You are removing bromine from 1 carbon and hydrogen from another carbon to get CH, the triple bond CH. This is what you are trying to get, okay, by removing this HBr. But This dehydrohalogenation, because double bond is there, is done by sodium amide. Okay, amino sodium rather. Okay, NaNH2. So I'm repeating it. If it is simply CH2 in place of this one, if it is CH3, CH2Br. Okay, so I am writing it like CH3, single bond, obviously, CH2Br. From here, I can do dehydrohalogenation by alcoholic KOH as I did here, because here I had single bond. So in this case, bromine will be removed from one carbon, hydrogen will be removed from another carbon. I will get CH2, this CH2, double bond, this CH2. This is something we have talked about in preparation of alkenes. But the problem here is, in this case, we do have hydrogen and bromine, but there is already double bond. So alcoholic KOH is not used. In that case, NaNH2 will be used. However, both the steps are dehydrohalogenation. So from vicinal dihalide, it happens in two steps. In first step, we can use for dehydrohalogenation, we can use alcoholic KOH. In second step, for dehydrohalogenation, we have to use NaNH2. Write this reaction, memorize. Having said so, in few guides, it is written only alcoholic KOH to show that you get ethyne, which is not correct. Now the third one, from tetrahalide. Tetrahalide means you have 4 halogens. Okay. So in this case, you have here 2, here 2 halogen, total 4. It is very simple. You get it reacted with zinc and you get ethyne. If you want to write this reaction, just write down. Just get it reacted with zinc and you will get ethyne. Now, if you remember, we have talked about in preparation of alkene similar reaction, but that was from vicinal dihalide. Okay, so BrCH2, CH2Br, we got that reacted with zinc and we got CH2, double bond CH2 and zinc bromide. So similar reaction for preparation of alkenes also, but there it was vicinal dihalide. For alkyne, that is ethyne, here you need to use tetrahalide. So here there will be 2 zinc molecules, here 1 only. So if you remember the alkene one, this is easy. Now if I ask you, what is the function of zinc? If you remember it like this, what is the function of zinc when reacted with halides? The function of zinc is dehalogenation, means it removes halogen. It removes halogen, means it combines halogen with itself. So the function of zinc in these reactions is dehalogenation, removal of halogens from the compound. Next one, preparation of higher alkynes from lower ones. Sometimes we will be using it in conversions as well. So you should remember this one, okay? This is the main reaction. We have compound, okay, sodium compound of an alkyne. We get it reacted with that halide, which we need the carbon there, okay? So suppose I have this one, okay, and I get it reacted with CH3, CH2I. Then instead of this CH3 getting attached here, I will get HC triple bond C, CH2CH3 getting attached here, CH2CH3. So depending on what alkyne I need to decide what halide I will be using here. Okay. But we don't have this compound stored. We actually prepare this compound. So to prepare that one, we use lower alkynes. So if you see now the heading is preparation of higher alkynes from lower alkynes. Lower alkyne means only 2 carbons here. Higher alkyne means you have 3 carbons. You can have 4 carbons as I just explained, depending on what alkyl halide you use here. So first to get the sodium acetanilide. Okay, this is known as sodium acetanilide. What you do, you get the ethine reacted with NaNH2. And once you get sodium acetanilide, you get it reacted with the appropriate alkyl halide, alkyl iodide specifically, because alkyl iodides are more reactive. You get higher alkynes. Write these reactions. Lower alkynes to higher alkynes. First get it reacted with NaNH2, then get it reacted with appropriate alkyl halide. So write it in this fashion, okay? Lower alkynes, NaNH2, you get sodium acetanilide, and then you get it reacted with alkyl halide, okay, I will say iodide, to get higher alkynes. So if you remember this thing, it will be easier. Now, before I move forward, just few minutes back, I talked about the function of NaNH2. What was the function of NaNH2? In previous preparation method, third preparation method, I talked about the function of NaNH2. What it was doing there? Tell me in the chat box, everyone. What is the function of NaNH2 in previous case? Okay, Ariman, but what? Your answer is incomplete. No, Sayak. Fine, Rida. But what it was doing, okay? What was its function? So suppose the reaction is given and you are asked, what is the function of NaNH2 there? What you will say? Mahi, no. So that Mahi and Sudit, if I combine your answers, then that will be complete. Rida is still incomplete. Aniruddha, no, it is not a catalyst there. Ariman, no, that's not the answer. Okay. In that case, the function was dehydrohalogenation. If there is double bond in the halide, you use NaNH2 for dehydrohalogenation. If there is no double bond, you use alcoholic KOH for dehydrohalogenation. I'm going back. Okay. The function of alcoholic KOH is dehydrohalogenation. The function of NaNH2 is dehydrohalogenation. The function is same. But alcoholic KOH will be used when there is no double bond. Then it can do dehydrohalogenation. NaNH2 will be used when there is double bond. And then we need to remove both halogen and hydrogen. In this case also we removed halogen and hydrogen. Okay. That's why we got this compound after removing one bromine, not this one, rather this one. This bromine and this hydrogen. And after that, we remove these two. So both functions here also, I am doing dehydrohalogenation by alcoholic KOH. Here also I am doing same thing, dehydrohalogenation, but because double bond is there, I will use NaNH2. Here in this case, the function of NaNH2 is just to produce sodium acetanilide. That is replace the hydrogen by sodium. Okay, so here what is the function of NaNH2? The function is this Na replaces this hydrogen, and this hydrogen combines with NH2 to give you NH3. Okay. So here function is different. It replaces hydrogen.